Okay, let's continue on. It is tempting to conclude that the nth root of a to the n equals a for all real numbers a. So that's something that we've probably learned before in Algebra 1. But Part D of Problem 2 shows that this is not the case. If n is even, then the nth root of a to the n is positive even if a itself is negative. So we learned that there. But here we have a negative, so we couldn't take the square root. For part C, we see that even though it would be tempting to say, oh no, the answer is just it's just -7. But we know that because we went ahead and squared this, and we got 49, and the square root of 49 is 7, that we wouldn't really necessarily have to say that. All right, so for any real a, the nth root of a to the n, a if n is odd, the absolute value of a if n is even. Okay, so we will look at that. It is easy to overlook this rule when simplifying radicals. It is particularly important that you remember it when the radicand contains a variable expression. You must include the absolute value when n is even. You must omit it when n is odd. Alright, so let's look at the first one. So we have the square root of 16x to the 8th. So when we take the square root, we know that the square root of 16 is 4. And then really when I do square root, all I'm doing is dividing my exponent with my index. My index here, remember when there's nothing there, there's a 2. So 8 divided by 2 is 4. So I get 4x to the 4th power. Well, because x to the 4th power is going to be non-negative no matter what I put in there, I'm always going to get it to be positive. I don't need the absolute value. So when it's even like that, I don't need the absolute value. All right, let's look at part B. So when we have an odd nth root or index, I don't need the absolute value. So again, I'm just going to take my 3 and divide 6 by 3, and I get 2. Divide n by 3, and I get 3. So a squared b cubed. All right, so, oops, I am so sorry. For the next one, I have the 4th root of x to the 8th, y to the 12th. And for this one, again, I'm just going to take, and this is an even number, so I am going to be using absolute value. So 8 divided by 4 is 2. And 12 divided by 4 is 3. Now the only one that I need the absolute value on is the odd exponent. So that's why I have x squared absolute value of x to the 3rd. So let's do some on our own. We have the square root of 81x to the 4th. Well, the square root of 81 we know is 9. And remember there's an invisible 2 here. So 2 divided by 4 is 2. And I don't need my absolute value sign because it's an even exponent. Let's look at the next one, the cube root of a to the 12th, b to the 15th. And again, I'm just going to take this 3 and divide it. So that's 12 divided by 3 is 4. And 15 divided by 3 is 5. And because it's an odd index, I don't need my absolute value. And then the last one, the 4th root of x to the 12th, y to the 16th. Again, I take this 4 and I divide it by 12. I get x to the 3rd. It's an even index and odd, so that's going to be absolute value. And 4 divided by 16 is 4. I hope that this helps.